All right, all right, all right, all right. Welcome to LaserBeam Live. I believe this is show number 6. If you guys are watching, I want to thank you guys for joining. Everybody in the chat, I saw Koala Carving was in very early. Nicholas, Bill, Bucky, or Dana. Uh, how are you guys doing tonight? Hopefully, you guys are having a good night. As you can see, every time we start this LaserBeam Live, we have a bit more decorum to the stream. We add a little bit more better lighting. The guys in marketing are working hard to have a very beautiful setup, and I think this might be our best looking setup yet. Let me know. I am using the headphones. You guys said you liked it more, and I feel like it's easy rather than using a DSL or a XLR mic with the audio interface that's going into the USB. Figured it's just easier to use a USB microphone, plug it straight into the computer. If you guys like the audio, then we shouldn't have any problem. First and foremost, are we lagging here? Can you guys see the movement? Can you guys hear my voice? Thank you, Koala. Thank you for that. Awesome. Appreciate the feedback, guys. The guys at marketing, they really know how to make things look aesthetic and beautiful. And they kind of set this all up for me so that I could just walk in every the Thursday evening, sit down and like start the stream. So they did put a lot of work into this, making it look good. We kind of kept simplifying things until we had a really good looking stream, good sounding stream. And it was easy for me to do everything. They even lowered my desk here so it's way more comfortable for me to do a bunch of stuff. So I'm excited you guys are joining me. Um, we don't really have a big project this week. I know the original thought behind this show was to have a really cool project to do every 2 weeks. And this week we actually don't have a project. But what I want to do is I want to revisit the card stock that we were working with last stream because we were having these issues where certain lines weren't popping up right, and it was kind of just bugging me because it was almost like the first stream where we had a project where we didn't actually take it to the end point, that we didn't get closure on that project because it didn't come out perfectly. um, Grant from the forum, I'm sure if you guys are in the CNC Labs forum, you guys have probably seen Grant. He works with us very closely and does amazing work in the forum. He actually let me know what the issue was, and it was actually a EEPROM setting that was forcing the motors to actually delaying the motors shutting off, which when you're working with CNC routers, it actually makes for a smoother project and smoother kind of motor control. But when you're working with the laser, the new Gerbil firmware has a safety function for the laser so that if the steppers aren't activated, if the steppers aren't on, if the steppers aren't moving, then the laser cannot turn on. So essentially, what was happening was there was a delay that was set in the EEPROM settings, which is great for CNC routing, but actually when you're lasering stuff and we're moving very quickly, like we were with the cardstock paper, um, those delays are actually going to come up with these spaces and gaps in your text and your other stuff. I've never seen it happen when we're using stuff like wood, because I imagine our speeds are so low that 100 milliseconds of delay in the motors turning on and off isn't going to cause that same effect. But when we're moving a lot faster, like with the paper, or you might even want to move very fast when you're doing wood and that stuff, you can always put the power all the way up and run it a little bit faster. Or maybe you're going for a lighter design, maybe you're going for a lighter effect, you might run into that same issue that we did last week. So this week we're kind of circling back to our last project with the cardstock, and we're actually going to play with those settings, and we're going to essentially turn off the delay in the stepper motor using one of the EEPROM settings, and then rerun this code and everything like that. um, but first, because I would like to have more input from you guys in terms of what projects you want to see, um, why don't we take a moment and you guys just let me know what projects that you want to see on the next live stream? Because I do want to sprinkle in these types of streams every once in a while where we don't really have a big project to tackle. It's more just me one-on-one kind of answering questions or doing things like that, or maybe even going over common issues. We're definitely going to be focusing on the issue we had last week. But yeah, let me know if you guys have a specific project. Um, I am still working on prototyping a rotary axis. So I believe around the Christmas stream, I should have a prototype that can actually do some cool stuff. So definitely, I'm excited for that, and I will be streaming right through the holidays. The Thursdays don't fall on any of the major holidays, so we will keep the stream up during the holidays. If that's any solace to any of you guys. So, what is up, everybody in the chat? Grant, thank you so much for the tip on the EEPROM settings. We're going to be testing that out today, removing the delay in the stepper motors, and hopefully we get much better results. So yeah, if you guys have any project ideas or anything like that, just let me know, and yeah, we can jump right into it. We don't have to waste any time. So I'm going to start off in GSender, and this is the EEPROM setting that we're talking about. So $1, and it's called step idle delay. So the description that GSender gives for this EEPROM setting is that it sets a short. Sorry, just reading a comment. I hope that it works now with all the buildup you've given me. I really do hope. I really hope it works now too. But even if it doesn't, we can go into kind of troubleshooting mode, and we can kind of find out why, and we could just continue the steps of solving a problem. Because I'm sure you guys have these types of small issues all the time, and you guys kind of have to go through that same step of, messaging us, getting our input, going on to the software forums, finding out what other people think, and then just trying things out until you kind of fix your issue. So yeah, step idle delay $1 sets a short hold delay when stopping to let dynamics settle before disabling steppers. Value 255 keeps the motors enabled with no delay. So essentially, oh Dana, what was your what was your issue, Dana? Maybe it's going to co-align with what we're working on here. Um, Let me know. So essentially, Gerbil, the most updated version of Gerbil that we use, is going to want to turn off all laser movement if it's not getting any signal to the motor. Why is this? It's actually a really cool safety function, because let's say your stepper was unplugged and it wasn't getting any signal. You wouldn't want your laser to be firing if your motors aren't moving, especially if you're running a job. That means all the power would just be in one spot, and eventually you'd probably light something on fire. So the MK2 motors were humming. Was this after you removed the delay by putting this EEPROM setting to 255? Yeah. So I imagine because the motors are going to get a constant feed of current, we might be getting a little humming during our job when we do run it without the delay. But yeah, I will be changing that to 255 because yeah. So I imagine, like, my guess would be that because. Oh, let's switch that to 55, and let's apply the new settings. So we may be getting that humming because the motors are essentially never going to turn off. So definitely when you're not running a laser job, or if the humming is just a bit too disorienting for you, I doubt it, because the router and other things, even the laser driver, is going to be a little bit louder than the humming, I guess. But you definitely want to change it back if you're going back to using router stuff. For me, I just want to test to see if it'll solve the problem of our missing text from our card stock. Um, so I applied the setting, and I am essentially going to. We're essentially going to go back to our original file from last week. So this is the last file that we ran. Um, with the invitation. And I want to check it out and see if this solves our little issue. So we are on dip switch level 5. We have our settings all set from last week. So if you guys are curious about what speeds and feeds I'm using, just check out LaserBeam Live number 5, the Halloween edition, and you guys can get all that info there. But essentially what I want to do is I essentially just want to double check and see if we can solve our little issue here. So our EEPROM settings are saved, and I will keep an ear out for any humming just to make sure. So we were focused last time, so I'm just going to assume that we're still in focus. So I'm just going to zero it all and then move it to my start point. So that's about roughly where we want to start. I'll move it a bit more into the camera view so you guys can see everything that's happening. And we are still focused from our last. And I'm going to zero everything, and I'm going to put on my safety glasses. And I'm going to go ahead and start this job. I'm just going to double check that my EEPROM settings are saved. So my settings are applied. Obviously, these are the basics. Maximum spindle speed is going to be 255. Minimum spindle speed is going to be 0. And we're going to have our laser mode enabled. And this time we're changing one extra feature here. We're essentially turning off the step idle delay function. And we're going to see if that solves our text issue where we were kind of missing out on certain lines in the text. And I'm going to be listening for that humming. And I don't really hear any extra humming, but so I feel like we got much better results, but we were still getting some text that was that's not almost perfect. So we cut all the way through. So Dana asks, how are you evacuating the smoke? I'm in a very open garage. Our shop and the shop in the office is actually really open, and we have a garage door to my left. So naturally, the smoke just kind of evacuates and gets funneled to the garage door. So if I was in a kind of closed garage, I would look at inline fans and ducting. So that's exactly how CO2 lasers are evacuate the smoke is inline fans and ducting. So that might be another product that we can start to offer at some point um, is inline fans and ducting at a reasonable rate with a very high quality supplier. No promises, but that's something I'm interested in because I know most people aren't in a case like me where we have this big giant shop, and not only do we have this big shop, it everything kind of leads to the big garage bay doors over here. Uh, so we're kind of lucky in that regard, but I know not everybody's like that. So you might be doing this in your basement, in a not so well ventilated room. So finding good suppliers for inline fans and a cheap and quality ducting system, as well as a way to properly mount it in your actual on your actual long mill without having to 3D print or laser cut or CNC some custom bracket. So if you guys are interested in that, I can definitely look into that quarter one of 2023. I want to finish up a rotary axis. Maybe I'll leave it up to you guys. Which one would you rather have? A venting system? Thanks, Bill. I was not able to make it because in the video I'm actually I just wasn't in the office at that point. We were prepping to have Thanksgiving lunch, and I came for lunch, but I wasn't early enough to be in the video. So Andy and Chris kind of stood in for me and let you guys know all the new stuff with the new aluminum and copper system, the new diodes. So we actually were able to find a diode supplier. Um, that is a little bit more reliable moving forward in terms of the amounts that we could order. And we made the sufficient changes to the driver in order to step up the amperage that it's driving at. So your old diodes were running at 7 watts and 6 amps with a forward voltage of about 5 to 6. And these are running 6 amp, 7 watts output. And you're going to have a forward voltage of a little bit lower than the other one. So they kind of compensate in that. So these new diodes they can reach the 7 watts. You can actually drive them higher than our old diodes and actually reach about 7.58 watts. Although once you start pushing it like that, you're going to drop reliability by a lot. So we chose to make the new sets of drivers only work. We actually did ship some of these out to some people, and in our testing, no, you weren't able to notice. So yeah. Are you guys talking about this desk, or are you guys talking about my work material? No, no, no. You guys aren't gonna have to buy a new diode at all. Um, it's just the supplier end. So um, the diodes that are our first manufactured diode, like the first diode that we used for manufacturing these, um, sometimes there was stock issues. It was hard to get a lot of the stock because they're so rare and they're so well known for their quality. Um, we were able to find a different supplier for diodes that had the same power output, but in terms of how much current they draw versus how much voltage they need, it was kind of reversed. So the other ones had 5 amp and a lower or a higher forward voltage, and these ones use 6 amp and a lower forward voltage. So essentially we just changed a few resistors in our driver design, and we were able to compensate that change. So we already have those prepped and ready. So whenever we run into another drought of the first diodes, we will make the switch over to the new diodes that we have sourced, the new diodes and the drivers. But no, they are the way they run. They output the same amount of power, so you don't need to swap. Um, so yeah, yeah. So it was essentially just like um, the first diode. We never knew if like next month they could let us know like, hey, these diodes are out of production. The manufacturer doesn't make them anymore, and those diodes were so rare at the time that we would have been in a very vulnerable situation if the large manufacturer decided to put those diodes out of production. So, and they're just very hard to source. So, because just about every company that actually has a true 7-watt diode, or some companies double up to 7-watt diodes and put out 14-watt models. Um, all these companies are pretty much trying to source the same one diode. So another diode manufacturer came out with a new diode, a different manufacturer, and it's way more abundant in stock. So a lot of these other companies are also starting to use these diodes. We ended up testing them when we ran into a bit of a stock drought in terms of the diodes and the drivers. So now, because we never wanted to be put in that position again where we couldn't provide the quality and the output of the lasers to our customers. So we started testing those suppliers. We got a lot of those in stock. We got the drivers changed to be able to drive those new diodes. And essentially, the two systems are identical in power output, but we had to make slight changes to the drivers so that they would match up in terms of the actual current that both of them need and the forward voltage that both of them need. And that's what Andy was talking about in the shop tour. um, so yeah, let's take a look at our new one. So as you could see, we had much better results. Oop. So we did have much better results. It might not be hard, it might not be easy to see because there are still small gaps here, like in the A, in the O, in the I, and in the N, the V, and the I. So you can see we're still having this issue. And although we improved our process, what the issue actually is that the white paper will actually some of the absorb or it will actually reflect some of the light. So essentially, what's happening is that the white is reflecting the light that we're trying to fire into the paper. So instead of actually absorbing the light and burning the material, it's actually trying to reflect the light. So, oh, no worries. It was still a good try, and it was still something interesting. So, you know, if you ever run into that issue with other materials, right? I want to see if this will happen on the on our on our wood. So this is about the same size. So I'm actually going to run this the same job at the same settings, and theoretically, if we're looking at the optics of it all, we should not have an issue um, running this job on the wood, because the wood will absorb the energy a lot better than the paper will absorb the energy, just because of the color of the paper, right? So we ran into that same issue when dealing with semi-transparent or transparent acrylic, where depending on the color of the substance, the color of the material, the transparency of the material, sometimes it's not going to want to absorb that power, and you're going to run into those issues. So if you have a non-colored, and actually, you know what, an even easier test of this. I'll be right back, guys. I'm gonna grab some colored construction paper so I can show you guys, and hopefully, I don't know what's gonna happen. Theoretically, the science tells us that if I run the same job on construction paper, we'll have a much better time because the construction paper will absorb it instead of actually trying to reflect it. So that's a good test. I'll grab a few colors and we can go test those out. So in order to test our theory here, I got three different pieces of construction paper. So they're not regular paper; they're thick, just like the cardstock. Um, but they're all three different shades. So we're gonna test against our white to see what level of absorption we're getting through the different colors and different shades. It's exactly so the paper itself is not going to be a consistent material. The makeup of the paper is not going to be 100% consistent. It happens that way even for wood, where some pieces of a piece of wood will absorb more light versus other pieces of the wood, and that's just based off the color, the makeup of the wood, the density of that specific area, and so on and so forth. So what I want to try is different colors and see if that same issue happens with our different colors. So we just tried white. So I want to try something a little bit brighter, but also will have a little bit less reflective value than our white piece of paper. So I'm going to run the same job, but I'm going to run it on some yellow. So I'm just going to go home. And I'm going to run the same job and I want to see what happens and see if my hypothesis is right or maybe I'm incorrect and we still need to find things to improve this process. So let's see what happens. Oh, I'm going to go to all zero and make sure our driver's on. And I want to see if we're going to get the same ones. Are the missing lines in the job going to appear in relatively the same spot, or are they going to? Is it just totally random based on the makeup of the paper? That's kind of what I want to test here. Yeah, Skeletor has been retired. He was a seasonal hire, and the season is over, so we have to let him go. You know, he got a very hefty severance. He got a very hefty severance package um, because none of us want to be haunted in the afterlife. So we let him go. So I'm actually super curious. Again, I'm where you guys are. I don't know if this is gonna work. I don't know if it's gonna make a difference. Um, you know, there's theories and there's science, but then when we actually put it to the test, sometimes things shake out differently. So I don't know if that's perfectly gonna be the problem. All the white paper and this construction paper are all relatively the same thickness, so we should be able to run the same jobs and we should have the same outputs on the actual material. And the only difference should be pretty much the color of the material when we test all three. So you know, if we find the same issue popping up with all three, then obviously it's not the reflectivity of the color of the paper. It has to be something else. And Grant, I do hear the squeal, or not Grant, Dana. When the job is finished, I do hear the whining. Yeah, you can see the A does look a little bit better. As you can see, the A is going to look a little bit better. So this is the one we just did. Um, the one we just did. So we still have gaps. And this is the one we did last stream. So you can see there's less gaps, but we're still having issues there. Ethan, what type of material are you using? Are you using paper? In terms of if you're using like construction paper or cardstock paper, um, in our last stream, I was playing with different settings, and we kind of saw which settings worked best for cutting construction paper or last stream was cardstock paper. Um, so yours using the 3 millimeter plywood. Um, so for those settings, if you're cutting these settings, uh, so Ethan, the settings for these I actually have in the resources, and the only change is that I might add an extra pass. I might actually add an extra pass or two um, in terms of how many cuts you're doing. So I'm gonna put this on the screen for you. It's in the so just to help out Ethan. So these are the settings I use for cutting when I'm cutting 3 millimeter plywood. These are the settings. So the only thing I would change for 4 millimeter is I would change the passes from 3 to about 4 or 5. Right. So I would do about 4 or 5 passes, and then I would change the number of Z steps per pass. So I'll change the size of the Z step per pass. So you take the thickness of your material. So if it's 4 millimeters, I might do 5 passes, and then to get the Z step per pass, I would just divide 4 millimeters by 5 passes, and then whatever that number is going to be your step per pass. Because every time it steps down, it's going to drop down by that amount after every pass. So 5 passes should get it right to the bottom of that material, or um, it should drop the same size as the thickness of that material. So Bucky said that he gets better results when um, when you don't when you don't do your job on flat footing, which is what I would suspect happens. Yeah, so metal grates will improve your quality of cutting because the power gets to cut all the way through instead of getting trapped in your waste material. So you will have a better time cutting straight through to something like a metal grate. Yes, the G8 or the G7 is a good thing to do if you're doing both cutting and engraving. So the G7 and G8, that's a perfect mix. So if I had to choose a lens for both cutting and engraving, I'm using the G8. If I was just doing cutting, I would use the G2. Out of laziness, I use the G2 just because it's stock. And when I'm using the 3 element, it's because I'm just engraving and I want the finest engraving. Yeah, so honeycomb grill or a metal grill would fit perfectly. And as you can see, the text is perfect. So that kind of proves our little experiment here. It really is the color. The color will absorb better, and it wasn't our settings there. So you can kind of see that where it was the same job, the same project, the same thickness of paper. The only difference was the color. And because white is the most reflective color, um, we're going to see that any other color that's a bit darker is going to absorb more of that power and have a better job. So it ended up being the color of the paper and not the setting itself. So, yeah, so we all learned something today. Um, So what I want to do is I kind of want to get your guys' input on which add-on. Yeah, Grant, I'm still set to 255. I'm still set to 255 with the yellow. I'd be interested to try. So for Ethan, if you guys want the settings, they're in the laser resources. Just go to material guides. So Raphael, I'm interested in how to align the laser to the router, being they are offset from each other. So I can do a little demonstration for you guys if you guys want. So in the settings, we have spindle and we have the axes offset. So in the axes offset, we can go into that and we can add an offset for the router and the spindle. So let me grab my calipers and then I'll measure everything down and then I'll show you how the offset function works for you. So I don't have my calipers handy right now, and I don't want to run to the other side of the office. So I'm just going to use some arbitrary numbers, or let's see if we can let's see if we can figure this out using our open source resources. So let's see if we can figure this out. Hmm. So first, I'm going to go to the long mill MK2. I'm going to go to advanced. I am going to go to open source. And then I am going to go what I want is the router mount. So that may be in the main. So what I want is the router mount. So let me find the router mount. Hmm. So we'll go to the 30 by 30. And we'll go to the router mount. So essentially, we want the length of this, which is 82.55. So we have 82.55, and our mounts right in the middle. So for the Y, our offset should be halfway through that. Let me think about this. I want to do this. I want to do this live. So we are pretty aligned there, and then so what we want is this divided by 2. So we want to unselect this. We want to select that. That's 88.9. So it's going to be 44.45. So we are offset by 44.45 millimeters. Then we are offset by the thickness of the laser mount, which I believe is about 3 millimeters. Yes. So we have 44.45 plus 3 millimeters, so 47.45, and then plus half the thickness of the aluminum is because the diode is going to be centered to that. So plus it's 40 millimeters, so 20. Oh, hey Jack, thanks for joining the stream. Uh, so we need the thickness of the laser itself, and then we can divide that by 2 and add that to 47.45. So 1 sec, I'm going to pull up some measurements from my phone for the laser. I just have to, let me just pull that up for you guys. Okay, so I got the drawings for the laser here, and we are working with 40 millimeters. So it's going to be 20 to the middle, so we're working with 67.45 on the X, or on the Y, so, and then we're pretty centered, but there is a slight offset. So let me try offsetting our X by 67.45. So with that setting, I should be able and then switch back to laser mode and go to 0. So now every time I switch from spindle to laser, it's going to offset by 67.5 millimeters, which is if you're mounted on the side, then it's 67.5. But if you're mounted on the front, it's going to be different. And then if you mount it on the front, then it's going to be offsetting the Y. And then if you have a larger router mount, then the distance is going to be different. So what I can do is I can get all the offsets for all the different router mount sizes, and I can do a tutorial next stream on how to first we can calculate it, and then we can provide all the different offsets for you guys. So um, does that sound like a plan? I feel like that's a good plan. I kind of just started playing around with it, and I think I got a pretty good kind of system here where every time you offset it and then you go to zero, it's going to offset by the amount that you put into your laser spindle, your laser axis offset. So I offset it by 67.45, which is half the thickness of the router mount. So half the width of the router mount. So that's center of the router. And then the thickness of the laser mount plate, and then half the width of the Yeah, and then half the width of the actual aluminum heatsink, so that it's offsetting by all those distances. Half the router mount plate, the 3 millimeters of the laser mount plate, and then half the distance of the aluminum heatsink, because the diode sits center in the heatsink and your router mount sits center in your router mount. So that's kind of how I got those formulas. Yeah, a formula would be just as easy. Yeah, yeah. So yeah, so exactly. So Nicholas, if you were on the other side, then it would just be a negative value, and then every time it would just offset the opposite way. So go to zero, zero changes. So now we're kind of yes. So Dana, theoretically, if you wanted to, um, if you wanted to, you could use a touch plate, zero everything. Yeah, it will zero your X and Y, but not your Z. Okay. So you're going to zero your touch plate to the material. It's going to go to the material. And then you're going to click spindle off laser mode. You're going to click go to zero. It's going to move over the offset amount. Yeah, I understand. Z is the most important. That's something we could look into for add-ons. So I want to get your opinion, because the me talking to you guys, there are small issues that you guys are all trying to solve that we could help make a lot like we could help yeah, we could help you guys in terms of add-ons for the laser and making add-ons that are worth wild for you guys. Um, but how what is the best way, what is the best product for you guys? That's essentially what I want to get a rundown on. So I think I will be sending out a survey for all the customers of a LaserBeam, the people who have opted into our email list for the LaserBeam. Yes, because there's rotary axis. Two, there's uh, particulate exhaust system, so inline fan and ducting system, and selling different lengths of fans, or selling different sizes of fans, and then figuring out a mounting system, probably a magnetic mounting system that works with the dust shoe mount, something that could slide on just as easy the dust shoe slides on, but with a inline fan, and then enough ducting. Or maybe we just sell the mount and the inline fan, and you guys purchase the ducting, or we have different sizes of ducting, so you guys can choose the length. Um, so there's exhaust system, there's rotary axis, there's huh, what else? What other projects or products would you guys want to see? There's uh, there's lasers, there's a laser add-on that I could make. So you guys are saying fixed lens and a removable laser mount to focus. So there's that we can work on. There's a ton of different things that we could work on. But if you had to have one first, which one would it be? So we got two for rotary. Grant says or Jim says rotary. Grant says rotary. What would you guys want to see in terms of lasers? Let's say rotary, exhaust, and there's a laser system that we could do an add-on for that would essentially create your starting point with a very non-burning laser, like a very light laser. Rotary, so that's three for rotary. So, I'm gonna put that question out to the customers and see what you guys want me to focus my time on first, because we are coming up on the year anniversary of shipping our first laser beam. So, okay, so we have one for exhaust. So we have one for exhaust and like three for rotary. So exhaust or rotary is kind of the two front runners here. So an exhaust system, a rotary system, we could do spoil boards. We can do an auto, like we could do a laser start function. So you have a very light laser that marks out your X and your Y in terms of where your laser should start. That's a very plausible product that I could develop for you guys, so that you guys have a visual marking. So we got another exhaust. So spoil board, exhaust, rotary, rotary exhaust. Nice one, Nicholas. You snuck it in there. Uh, Air assist. Are you talking about? Yeah, we. Are you talking about a screw-on air assist? Our only issue with the screw-on, the only reason why a screw-on air assist with an actual um, a pump for air, pumping it through how most CO2 lasers get their air assist done. The only reason I didn't go that route is just because the adjustability. So, Raphael, the rotary axis is for doing round items. So, it would essentially sit and it would replace your y axis, and then it would just rotate your item. And instead of, you know, engraving on something flat, you're essentially just rolling up the axes, and you're doing the same job just this way. So rotary, and a mount could be a different mount for the fan. So 3D printed exhaust add-on with a pneumatic piping out from the yellow corner, yellow cover. So yes, so there's different ways we could do an exhaust system, and with some ducting included. We can do collapsible ducting. We can do different lengths so people who have different situations can get the air. Um, we can do kind of the alligator clamps or the screw-on clamps to make sure your stuff is tight on your exhaust, and then you can duck that to wherever you need it to go. And just like the dust shoe, it'll kind of keep things handy. No, the guys, the rotary axis would really not be hard to DIY, but I know a lot of people, just like the exhaust system, wouldn't be hard to DIY. A lot of people just like something to be able to purchase just to save them their own time. And obviously, we have the luxury of ordering in bulk and testing out multiple suppliers to make sure that we're getting kind of the best electronics rather than you guys kind of buying things. But we're a DIY company. A lot of our stuff is most of our stuff is open source. Guys, if you want to make your own, honeycomb grill for your waste material, you want to make your own exhaust system, you guys want to make your own, rotary axis. That's totally up to you guys. That seems like a fun project for you guys. So, what about the blue coolant piping like foam? All automotive plans. You will only need a tiny fan to exhaust out. That's definitely a possibility. That's definitely a possibility. That's something I can look into. So we'll be doing, testing based on which one. I will get to both. Like those are the two I think most asked for add-ons for the laser is going to be um, ducting, an exhaust system, and a rotary axis. So I do believe I'll get to both. Like hopefully by mid next year we'll have both that are ready to go. But I would like to focus on one for quarter one of 2023. So that's kind of my focus is to prototyping stuff now so that we can release new add-ons for quarter one of 2023. And that's going to be based on the responses that I get from you guys, based on what you guys. Hey, Koala, send me a ticket. Koala, if you send me a ticket with the word laser in it, it'll go directly to me, and just you can message me all your ideas, and we can kind of go back and forth from there. So that's the thing. Because we're not producing a wild amount of smoke. Um, if we had an inline fan that was close, like where your dust shoe sits, it would exhaust most of the particulate. Um, yeah, an inline fan very close to your that's moving, like right, like just like where the dust shoe is, an inline fan where the dust shoe is, and then ducting that inline fan to wherever your output is, window, garage door, a regular door, whatever that is. Um, that wouldn't be too hard, and it would definitely collect most of it. Yeah, exactly. So it does end up working for most of it. Just inline fan inducting, I think is the way to go. I think that's the simplest, and it'll get rid of most of the particulate. I'm not saying it would be perfect, but for anybody who is doing things indoors or doesn't want to have an entire garage door open during the winter, this definitely would be a better solution. And we wouldn't be like charging incredible prices for a fan exhaust system. So it's definitely something I want to look into. Yeah, so Glowforge is a really cool company. They make very customer facing products, so they're very easy for people to get into. And yeah, having a whole exhaust system is a little bit pricey because then you start getting into like HEPA filters and all that stuff, and then being able to replace things. All right, Koala, you take care. Have a good evening. Thank you for joining us, and I guess I'll talk to you in the emails. Yeah, Jack, I'm in. We're in the same situation. I'm in the same situation as you, Jack. I'm in such an open area, and I do have a garage door. Like I can feel uh, the draft coming from the garage door. So like I'm in such a well ventilated area that I don't need an exhaust system, but I definitely want to. Like you said, I could definitely see the need for some person. Even in my personal workshop, I don't have any windows, so I actually exhaust an inline fan into a set of filters. So I kind of created my own like air filtering system so that I don't uh, just bellow smoke into my work area. Um, so Bill, I would even look at mounting onto your dust shoe mount, right? Because then you can create kind of like a magnet system that will clip on. If you're trying to do something DIY, you might be interested in trying to just clip on something from your dust shoe, which kind of gives you like the best area and something that will move with your system as it goes. So it's always going to be the same distance away from your laser and where the smoke is being created. So yeah, Jake, in terms of Glowforge and filters, those end up being very expensive. But if if we do end up start looking at filtration systems and CO2 lasers, then that's obviously a way to go because CO2 lasers are enclosed and they do create a lot more smoke than a diode laser could because it's just moving so much faster and it's so much more powerful. So yeah, Bill. Again, I would look at just dust shoe mounting and see if you can get a bracket working there. That would be my when I like go to design something. I would go off like I'm gonna start by going off something I can work with um, the dust shoe mount because it's already there and the dust shoe is so removable that it would be it would be a pretty cool workflow to just like remove the dust shoe and then add your air your filter for your smoke. All right, guys. Do you guys have any more questions? This might be a little bit shorter of a stream, but if you guys have any more questions, oh, awesome! Yeah, if you come up with a great design, definitely. If you feel like would like to share that design, Bill, just send me just send in a ticket with the word laser in it, and it'll go directly to me. And I would love to see your design. Yeah, Jack, that would actually be really cool. If you end up 3D printing a cool little dust shoe bracket mount, send me a ticket, send me some pictures so I could take a look. That would be so cool just to help my brain on like what's gonna work for you guys in the future. Obviously, if you're more into like making your own stuff, you might not purchase one from us if we end up releasing an exhaust system, but it's still great to see what's working for you guys. Yeah, Jake, no problem. This is awesome. This is becoming really fun for me. I really liked taking a break from the more, you know, uh, project oriented stream and just to come on to you guys and just share some things with you, try out some things, test some theories, play with some settings. So yeah, I thank you guys for joining again. And thank you guys for kind of keeping me company and adding your input. And I'm learning from you guys probably just as much as you're learning from me. So it's awesome. Oh yeah, so 2 weeks is your Thanksgiving. So guys, if you guys can't attend the next live stream because of any Thanksgiving activities to our brothers down north, or no, we're up north, down south, our U.S. citizens, our U.S. customers, our U.S. supporters. If you guys can't make the next stream, that's totally fine. I understand. It'll be a super polite stream because it'll be a bunch of Canadians. I know that was a bad joke. I'm sorry. Guys, I appreciate all your support. You guys are literally the best. Thank you, Jack. Thank you, Jack. Thank you, Dana. Love your support. You guys are the best. You guys make this make coming in, for the live stream worth it. We're always trying to improve. I'm glad that you guys like the new set. I'm glad you guys like the new mic situation. I'm hands free. No more mic in one hand. No, thank you guys. You guys are the best. If you guys have any other questions or any other comments, you guys want to let me know. Just I'll be around for 2 more minutes before I end the stream. But yeah, you guys have a great night. Again, I want to thank you guys. I think this is episode number 6, if I'm not mistaken. And my whole goal is to do it consistently, um, no rescheduling, no breaks for a year, and then see where we want this show to evolve. Grant, have a great time at work. Thank you so much for the kit or for the idea. Dollar sign number one, guys. If you do it, make sure to revert it back before you do any routing, or else you will get this humming. You will get this constant humming, and it might also affect the way your routers work the job. So it was a good tip for the laser, but you want to change that back and revert that dollar sign one setting back to 100 or whatever preferred delay you have. The stock setting is 100, but you want to revert that back. So thank you, Grant, for the idea. All right, guys. You guys are the best. I will catch you guys in 2 weeks. You guys have a great night. So take care. And I'll catch you guys on LaserBeam Live number 7. You guys can send in tickets, use the word laser. If you guys have any ideas for the next live stream, if you guys have a project, if you guys want to just mess around and do something like this again, let me know. Your feedback is appreciated. Till the next time, just like Nicholas said, till next time, uh, my name is Ikenna. This is LaserBeam Live, and I will catch you guys on the next one. All right. Good night.